Evaluate the given integral y minus sin x into dx plus cos x into dy, where C is a triangle whose vertices are 0, 0, pi by 2, 0, pi by 2, 1. Using direct method as well as Green's theorem, we should solve this. With the help of the three vertices, we have constructed a triangle. This is 0, 0, this is pi by 2, 0, this is pi by 2, 1. This is line OA, AB, then BO. See, these three vertices are present here, 0, 0, pi by 2, 0, pi by 2, 1. Now we should solve the problem using the direct method. For that, consider the OA line. For the line OA, y equal to 0, then dy equal to 0. Along this line, the value of y equal to 0, then dy equal to 0. Therefore, the above integral is y minus sin x into dx plus cos x into dy equal to y equal to 0, therefore this term is 0, minus sin x into dx. If y equal to 0, dy equal to 0, the second term is also vanished. This is the integral. Now we have to apply the limit of x. Lower limit is 0, upper limit is pi by 2. 0, pi by 2. This is equal to minus of integral sin x dx, which is equal to minus of minus cos x, limit varying from 0 to pi by 2. Minus into minus plus cos x, limit varying from 0 to pi by 2. Cos pi by 2 is 0 minus cos 0 is 1. So the integral value is minus 1. For the line OA, the value of the integral is minus 1. Now for the line AB, take the line AB. Along the line AB, the value of x is constant, x equal to pi by 2, fixed, x equal to pi by 2. Therefore, dx equal to 0, because it is a constant. If we differentiate a constant, we can get 0. Then the value of y is changing from 0 to 1. Verify this. 0 to 1. Now the integral y minus sin x into dx plus cos x into dy equal to, for the line AB, y equal to 0 to 1, the limit x equal to pi by 2, therefore dx equal to 0. If you put dx equal to 0, the first term is 0. This is vanished. This entire is 0 because dx equal to 0. Then the rest of the term is cos pi by 2. Instead of x, you have to put pi by 2 into dy. Here, cos pi by 2 is our 0. Cos 90 is 0. So the entire integral is vanished. So for the line AB, the integral value is 0. Next we have to go for line du. At b, x comma y, which is equal to pi by 2 comma 1. At o, x comma y equal to 0 comma 0. Therefore, put y equal to 2x by pi. If you put y equal to 2x by pi, in x, if you substitute pi by 2, we can get the value of y equal to 1. See here, at the point B, the value of x is pi by 2. Value of y is 1. Here, if you put x equal to pi by 2, we can get 1. Suppose x equal to 0, then automatically y is also 0. We can get this point. Now, at the point B, x is pi by 2, y equal to 1. At the point O, x is 0, y is also 0. Therefore, we have to select y equal to 2x by pi. Then dy equal to 2 by pi into dx. Now, the integral y minus sin x into dx plus cos x into dy, which is equal to 2x by pi. This is the value of minus sin x entire is multiplied by dx plus cos x into dy. dy is 2 by pi into dx. This is 2 by pi into dx. Now the limit is, all are expressed in x. Now we are talking about the BO line. So the limit is pi by 2 to 0. Lower limit is pi by 2, upper limit is 0. Now we should simplify this. This is 2 by pi integral x dx. Integral x dx minus sin x dx. So here 2 by pi x dx minus of sin x dx plus 2 by pi integral cos x dx. Limit varying from pi by 2 to 0, pi by 2 to 0, pi by 2 to 0. This is 2 by pi, x dx is x square by 2, limit varying from pi by 2 to 0, minus of integral sin x is minus cos x. So this is plus cos x, limit varying from pi by 2 to 0. 2 by pi integral cos x is sin x, limit varying from pi by 2 to 0. Now we have to simplify. This is equal to 2 by pi x square by 2, pi by 2 to 0, plus cos x pi by 2 to 0, plus 2 by pi sin x pi by 2 0. Now simplify this, 2 by pi upper limit is 0 minus lower limit is pi square by 8. If you apply the lower limit pi by 2, pi square by 4 into 2, pi square by 8 plus cos 0 1 minus cos pi by 2 0 plus 2 by pi into sin 0 0 minus sin pi by 2 1. This is equal to minus pi by 4 284 pi square pi minus pi by 4 plus 1 plus 0 2 pi by 2 minus 2 by pi. This is equal to minus pi by 4 plus 1 minus 2 by pi. This is the value of the integral for the line BO. Now the integral value for OA plus AB plus BO we should calculate. Integral y minus sin x dx plus cos x dy equal to integral OA plus integral AB plus integral BO. See here, OA, AB, BO. Then we have to put the quantities inside the integral. You know that integral OA value is minus 1, integral AB value is 0, integral BO value is this much, minus pi by 4 plus 1 minus 2 by pi. Then the total result is minus 1 plus 1 cancelled out, so minus pi by 4 minus 2 by pi. This is the value of the integral using direct method. Now we have to solve the same integral with the help of the Green's theorem. For that, write down the given. Given is m into dx plus n into dy, which is equal to integral of y minus sin x into dx plus cos x into dy. But the Green's theorem in a plane is m into dx plus n into dy, which is equal to double integral of dou n by dou x minus dou m by dou y into dx dy. This is our Green's theorem. Now from this, the value of m equal to y minus sin x, then n equal to cos x, then dou m by dou y is equal to 1, dou n by dou x equal to minus sin x. Therefore, dou n by dou x minus dou m by dou y, which is equal to minus sin x minus 1. Now the integral dou n by dou x minus dou m by dou y into dx dy, which is equal to integral x equal to 0 to pi by 2, y equal to 0 to 2x by pi. Then substitute the value minus sin x minus 1 into dx dy. Integral dou n by dou x minus dou m by dou y into dx dy equal to 0 to pi by 2, then 0 to 2x by pi. Minus sin x minus sin x minus 1 into dx dy minus sin x minus 1 dx dy. Now this is equal to 0 to pi by 2 minus sin x minus 1 into dx integral dy limit varying from 0 to 2x by pi. This is 0 to pi by 2 minus sin x minus 1. Integral dy is y. Then apply the limits 0 to 2x by pi, which is equal to minus sin x. Here we have to put on dx minus sin x minus 1 into 2x by pi into dx, which is equal to integral minus 2 by pi into x sin x. See here, minus 2 by pi x sin x, then minus to minus plus, just you have to take out this is minus, this is minus 2x by pi, entire is multiplied by dx. Now the limit varying from 0 to pi by 2, carefully check it. Minus 2 pi by minus 2 by pi into x sin x, then minus 2x by pi into dx. 2 minus 2 by pi into x, entire is multiplied by dx. Here take out minus 2 by pi commonly outside, 0 to pi by 2 x sin x dx. We have taken out minus 2 by pi outside, therefore this is plus integral x dx. Now we have to solve this. Minus 2 by pi x sin x dx, x sin x dx integral limit varying from 0 to pi by 2 plus integral x dx, integral x dx. Now we have to integrate this. First, x sin x dx equal to what? Evaluate this. Put u equal to x, then dv equal to sin x dx. Integral u dv, which is equal to uv minus integral v du. Therefore, integral x sin x dx, which is equal to uv x into, if you integrate this, you can get minus cos x. Cos x is the negative sign, minus of, once again v is minus cos x. Say the value of v is minus cos x. Instead of v, we have to put minus cos x. So minus to minus plus cos x into du. U equal to x, du equal to dx. Say this is the value. Now we have to apply the limits. Lower limit is 0, upper limit is pi by 2. Here also 0 to pi by 2. This is equal to minus pi by 2 cos pi by 2 0 minus of 0 into cos 0 plus integral of cos x is sin x, limit varying from 0 to pi by 2. See here, pi by 2 into 0, 0, 0 into cos 0, 1, 0 into anything 0, so the first term is 0, plus sin pi by 2, upper limit sin pi by 2 is 1, then sin 0 is 0, so the integral value is 1. So instead of this integral, we have to put 1. Now this is changed as, the value is minus 2 by pi, then minus 2 by pi into x dx, limit varying from 0 to pi by 2. This is equal to minus 2 by pi into x square by 2, then apply the limit 0 to pi by 2, which is equal to minus 2 by pi minus 2 by pi into, this is actually pi square by 8. This is equal to minus 2 by pi minus 2 divided by 8, that is 1 by 4. This is minus pi by 4. So the answer is minus 2 by pi minus pi by 4. This is the value of the given integral using Green's theorem. In the ordinary direct method, we have solved that. The answer is minus pi by 4 minus 2 by pi. Here also we have had the same result, minus 2 by pi minus pi by 4. Now we have evaluated the value of the given integral in the given two methods.